Good morning, everyone. My name is Axel,
My name is Nagib.
I'm Harshini.
I'm Yang.
and today we will be presenting our prototype solution, WorkSafe Plus, to resolve a real-world problem revolving around smart factories. The first thing to do was to identify our problem. So we asked ourselves, how can we develop a smart and sustainable system which is capable of monitoring the environment and detecting motion in critical areas to enhance worker safety in workplaces?
So here we introduce our project where WorkSafe Plus is a safety system that helps protect workers in dangerous place. It uses sensors to track movement, check the environment, and alert workers if they get too close to the machines. It also has RFID tracking to allow only authorized workers inside and warn about hazards like hot air by giving real-time safety alerts. WorkSafe Plus helps reduce accidents and make the workspace safer and more efficient.
So this is the research that we have done. One of which is we chose is minimizing the accidents in workplace. So according to the statistic in the global world, over 2.3 million workplace accidents occur globally each year, and many of the accidents can be minimized through the advanced safety systems by using our smart factory worker safety monitoring system. Monitoring workplace conditions and identifying potential hazards in real time to receive feedbacks and helping to reduce risks for workers in their daily tasks. As slip and fall are common in most workplaces, we have to monitor this area that account for 35 to 40% of workplace accidents. Then we have to do our routine inspections and maintenance of working surfaces that allows people in the industries to minimize the risk, as well as this allows the floor to reduce the slipperiness through maintenance check during working hours. This allows colleagues to place hazard signs to inform others that the floor is slippery, and this approach can be implemented across various industries from manufacturing to logistics, benefiting a large workforce.
This is the overview block diagram of our project where we used environment sensor, TOF, and light unit to be connected into our main M5Stack controller. We used PA hub to connect environment sensor and TOF together, which gives an output of LCD display with LED and dashboard. For our secondary M5 stack, we used servo motor and RFID to help us to give the output of LCD display and LED dashboard as well.
So for this slide, I'll be going through how our overall product look like. So on the first picture, you can see of how we created our prototype. And the second picture on the right is the secondary M5 stack. And below it is the main M5 stack. So this is our design implementation. As you can see, the secondary M5 stack is connected to the RFD server motor, and the main M5 stack is connected to the light sensor, TOF, and environment 2 sensor with the help of the PA hub. So with the first flow chart, it's the secondary flow chart. So this is the flow chart of how our secondary M5 stack works. So it starts off with the worker scanning on the RFID and seeing whether is it a valid or invalid personnel. So if it's a valid personnel, it will display the person's name, and there will be a counter which increase by one, and the servo motor will unlock the door. And there is a manual locking system which is by pressing button A. So if button A is pressed, it will lock the door, and it doesn't press button A, the door remains unlocked. And for the workers to leave from the room, they have to press button B, which unlocks the door, and then it will reduce the counter by one, showing that the room has one lesser person inside. And after 5 seconds, it will automatically lock the door. And the last part will be the authorized user to reset after the end of the day of the work. So for this part, there's only one card that is authorized to reset everything and to lock the door, auto lock the door after that. For the main flowchart, this contains all the TOF environment 2 sensor and the light sensor. So the first part, it will scan the light value. So if the light value is less than 200, the LCD will display that is too dark and have a white RGB that will turn on. And after 2 seconds, it will check the room brightness to verify whether the light value is still less than 200 or more than 200. So if the light level is more than 200, it will start checking the machine temperature. And the machine temperature has three different settings that we have set. There is one where it's less than 25 degrees. If it's less than 25 degrees, it will indicate that it's too cold and the RGB will turn blue and a speaker will buzz for 0.1 seconds. And the same thing, it will just wait for 6 seconds and check the room and go back to the same loop where it checks the room brightness first. And then if the room brightness is acceptable, it will check the machine temperature. So will be a common feature among all of the checking of temperature. It will always go back to the first part.
For our main system, over the next two slides, sorry, I will briefly explain how our code works. For our main system, some fixed text and some variable text are placed at specific locations on the M5 stack to display the temperature, light level, and distance and mode. It will start by getting data from the respective sensor before entering a continuous loop to check through these four conditions. If the light level is too low, if the distance on the TOF is below a certain level, if the temperature is below and also above a certain level, all of which will result in a change of LED color or the sounding of the buzzer to warn people nearby. For our secondary system, we too have some fixed and variable text on screen, and we will also be making use of the buttons. We made use of a total of 3 variables to track how many people have entered or left the room, and to lock and unlock the door. In the first part of the codes, we define button A to lock the door and define button B to unlock the door for a certain amount of time before locking the door again. Since this is restricted or secured room, the door must be locked at all times unless someone is entering or exiting the room. Speaking of entering the room, only authorized people with the key card may enter. We can achieve this result by making use of the RFID sensor to detect the unique identification of cards and only certain UIDs to unlock the door. On our second if statement, we can use a specific card to reset the system in case of any errors or to end the day with a clean record. With that, we have come to the end of our presentation, but that's not the end yet. Let's take a look at our demonstration. Next, we will demonstrate how our WorkSafe Plus works. In this demonstration, we get to see the RFID locking system in action. People with authorization will be able to unlock the door with their admin cards. Once inside, they can then push a button to lock the door behind them. The M5Stack also helps track how many people have entered the room since the last reset. If any unauthorized person tries to enter the room, the system does not recognize the UID of the card. Thus, the person would not be allowed to enter. The M5Stack's counter also doesn't increase unless the person with authorization scans their card. If anyone wishes to exit the room, they simply just have to push a button and the door will unlock. After closing the door, the system will then lock the door and update the counter on the M5Stack. We use 3 different sensors for our main M5Stack. First of which is the environmental sensor, which will measure the surrounding temperature. And if it is below a customizable value, the M5Stack will show too cold. If the surrounding has returned to normal working temperature, it will show normal. In our setup, we have made two additional modes which are customizable to warn others about the temperature of the room. In this demonstration, the first mode activates when the temperature rises above 26 degrees Celsius. The second stage will activate when the temperature rises above 27 degrees Celsius. We use red lights and a long beep to warn others about the dangerous temperature in the room that could be caused by overheated machines or fires. Our second sensor is the light sensor. In some cases of power outages and all the lights were shut off, the sensor detects the surrounding light has dropped below a certain level, thus causing the M5 Stack to turn on its light and show too dark. Finally, we have our time of flight sensor, which is responsible for warning others when they get too close to a machine in operation, especially those with exposed rotating parts that could cause injury or death in seconds. Instances where a person unlocks the door and more than one person leaves the room, the M5 Stack will not be able to accurately track how many people were left in the room. Thus, the person in charge can reset the M5 Stack located in the room with a special keycard, after checking that it is empty.